Have you ever imagined a universe where mysterious, colossal bursts of energy outshine entire galaxies? Today, we're diving into the enigma of fast radio bursts, FRBs, cosmic phenomena that leave even the brightest minds in astronomy puzzled. Welcome to Youniverse Revealed. Fast radio bursts are extraordinarily intense, short-lived bursts of electromagnetic radiation, mostly observed in radio wave frequencies. To put their power into perspective, these bursts unleash as much energy in mere milliseconds as our sun does in 3 days. Astounding, isn't it? These bursts originate from points unimaginably distant and powerful. Traveling billions of light years, they weaken over their cosmic journey, yet when they reach Earth, they're still detectable. Faint, but significant. It's like catching a signal similar in strength to a mobile phone signal from the moon. These bursts of energy give off really bright flashes of light. These fleeting flashes of brilliance last only a fraction of a second. Despite their detectability, their origins and nature cloak themselves in mystery, making them one of the most intriguing subjects in modern astronomy. Their elusive nature leaves scientists both fascinated and baffled. While some FRBs appear only once, vanishing as quickly as they come, others repeat, deepening the enigma. There's still a lot we don't know about the fast radio bursts and what makes them tick, so let's just sum up all of it in this video. Here is all that we know and all we don't know about these puzzling bursts of energy from deep space. Our journey through this cosmic mystery begins in 2001 at the Parkes Observatory in Australia, where the first ever FRB, originating from the small Magellanic Cloud, was recorded. However, this groundbreaking discovery by astrophysicist Duncan Lorimer and his team only came to light in 2007, when they identified it in archival data from the observatory. Lorimer, in a paper from the same year, characterized the FRB as a, quote, bright millisecond radio burst of extragalactic origin. This led to the burst being named the Lorimer burst. It was officially designated FRB 010724. Lasting approximately 5 milliseconds and not repeating, the Lorimer burst stands out as one of the brightest FRBs ever detected. This discovery led to subsequent investigations, which further solidified the significance of FRBs in the study of our mysterious universe. The discovery of the Keen burst, also known as FRB 010621, happened during the analysis of data from the Parkes Multi-Beam Pulsar Survey in 2011. Then, in 2012, the Arecibo Observatory, which used to be a radio telescope in Puerto Rico, found something groundbreaking. They identified the first repeating FRB, officially named FRB 121102. This burst looked like it came from a galaxy 3 billion light years away. It was the first time a telescope other than the Parkes Observatory found an FRB. This revelation was a big deal because it showed that at least in some cases, the source of these powerful bursts of radiation didn't just fizzle out after being emitted. It was a key step in understanding the nature of this mysterious cosmic phenomenon. The finding of FRB 121102 is, in a way, a revolution. This was crucial because it proved that these events weren't just localized to a single observatory or region in space. In the following year, the California Institute of Technology came up with the term fast radio burst to describe this kind of event, and since then it has become an official way of addressing these mysterious bursts of radio waves from space. In June 2022, astronomers using the Australian Square Kilometre Array Pathfinder, ASCAP, a group of 36 big antenna dishes, saw an FRB coming from 13 billion light years away. That was huge. This particular burst, labeled FRB 20220610A, is the farthest and potentially the oldest FRB ever witnessed. According to researchers, it might have happened when the universe was less than 1 billion years old. However, not all FRBs are super distant. Most of the ones scientists have found, including those just mentioned, come from galaxies outside our Milky Way. But here's something noteworthy. Astronomers have also stumbled upon a significant FRB that popped up right here in our own galaxy, making it a quite remarkable discovery. In April 2020, researchers using the Canadian Hydrogen Intensity Mapping Experiment, CHIME, and the Survey for Transient Astronomical Radio Emissions 2, STARE-2, a trio of radio antennas in California and Utah, they discovered a burst known as FRB 200428. It was a short one, lasting just 1.5 milliseconds, and it came from a relatively close distance, just 30,000 light years away. That was right at the center of our galaxy. On the flip side, the longest fast radio burst ever observed was FRB 201912221A. Scientists using CHIME first noticed it in 2019. Unlike the usual quick burst, this one hung around for 3 whole seconds, making it roughly 1,000 times longer than the average FRB. What's even more interesting is that it had periodic peaks, like a cosmic heartbeat as described by the researchers. Now let's talk about the theories and speculations surrounding what might be causing these phenomena. Scientists have been pondering this mystery for quite a while now. The prevailing idea is that some super energetic process in space, which we don't fully grasp yet, is behind these bursts of radio waves. Now they've got a list of potential suspects. First up, there are these super magnetic stars known as magnetars. Then there's the possibility that crashing pairs of neutron stars or colliding white dwarfs might be responsible for these intense bursts. Although astronomers aren't entirely certain about the cause, there are some clues. Since FRBs are so brief and last just milliseconds, they probably come from really compact objects. Why is that? Because light will have to travel across the object in the same tiny time frame it takes for an FRB to peak, then vanish. Also, the violent energy of FRBs hints that they might originate in some seriously dynamic and energetic environments out there in space. Scientists have followed some important clues, and they're pointing toward compact stellar remnants as a possible source. These remnants could be objects like white dwarfs or neutron stars. One leading suspect in the FRB mystery is a special kind of neutron star called a magnetar. Magnetars are neutron stars that spin really fast and boast the most powerful magnetic fields known in the entire universe. They can have 1,000 trillion times stronger magnetic fields than that of Earth. Now let's understand how these magnetars come into play. When huge stars finish their life cycle, they collapse as they run out of nuclear fusion fuel. They then leave behind a core, shedding their outer layers. This core, or the stellar remnant, with a diameter now wider than 12 to 20 miles, becomes a neutron star. This neutron star is now a super dense object that's collapsed to the size of a city on Earth, but with a mass similar to that of our sun. Imagine the energy it would carry. Scientists think that if this neutron star happens to be a magnetar, it could be a potential source for the intense energy we observe in FRBs. And wait, it doesn't end there. There's another intriguing scenario as suggested by the Planetary Society. It talks about something called a blitzar. Blitzars are sudden bursts of powerful radio waves caused by the rapid collapse of a supermassive neutron star. This neutron star should have turned into a black hole, but its super fast spinning somehow shields it from that fate. When these bursts come from far away in space, it means their source must be packing tons of energy. And do you know the best part of all? Some researchers have speculated that these signals might not be natural at all. There's a wild idea floating around that these bursts could be a sign of extraterrestrial intelligence. When the first pulsar was discovered, people thought the regular pulses might be coming from a distant civilization. They even nicknamed the source LGM-1, for little green men. We know it's a stretch, but it's part of the scientific process to consider all possibilities. Despite so many theories, researchers have no conclusive evidence that they indeed are the cause behind fast radio bursts. Scientists are doing all they can to figure out where fast radio bursts originate from. Currently, the top contender for their source is young and active magnetars, those highly magnetized neutron stars. And even though they've spotted hundreds of FRBs over the last few decades, their origin still remains a mystery.